This conference will now be recorded.
My screen is visible? Yes or no?
Yes,
Yes, sir. Yes.
sir. Yes,
Thank
sir.
you. So we'll start with how the booting process works in Linux actually. And if I'm missing something from the past which I've told, I might tell in next day. Please remind me because I may forget because I do have so many things in my mind to complete and to go ahead with. So I may miss. If something I'm missing, please remind me so that I do complete and I don't miss that information. Okay. So let's start with booting process of Linux. So first of all, if you have your, if you get your laptop, I mean new laptop. Let's say this is your new laptop. What are all things you expect here to be in your new laptop? When you buy a new laptop, you will check what is your hard disk. Okay, and what is OS? Is it with OS or without OS? Okay, you guys check. What is RAM? What is graphics card? Does it have graphics or not? Does it, how much RAM it is having? It's come along with operating system or not? It come with how much of hard disk? Hard disk also is having HDD or SDD. Many people may not know or may know what is SDD and what is HDD. Please go on Google, please go on internet and Google it. What is SDD? Okay. Sorry, not SDD, SSD. It's my mistake. Sorry. What is SSD? So either it's supposed HDD or SSD. And there can be many more things like do you like webcam, whether it is having or not, what kind of keyboard it's having, what kind of design it's having, what kind of build it's having, and there are several other things also. Does it have fingerprint reader or not? Does it have how many USB port it's having? Which HDMI port it's supporting? It's micro or the normal one? So there are so many things. You will you will consider all these parameters while buying a laptop. Okay, so here we are not going to buy a laptop, but we are trying to understand when you get a new laptop, what all things comes along with that. So these are all the things is going to come along with that. Let's say if you don't have this component, you don't have operating system installed in it, you don't have operating system, OS is not there. So what will happen? What you will get here when you turn on your system? There's no OS at all in this system. So I want reply
System
from
will
some
not.
people.
System will not
Okay.
run.
So when you turn on your when you turn on your computer, what screen it will show, and what should be the process of that? Can somebody tell me? Yeah,
Command
someone.
section will be command section will be shown.
Okay.
We have to
Any other?
install the OS.
Mhm. Any other reply? Yeah, it will show error definitely. Any other reply? Come on, there are so many engineers. I know that.
Sir, first BIOS will load, sir. Then the bootloader it checks for OS. Then if OS is not there, uh, then uh, in
It will
command
tell that
prompt only it will
it will
be.
tell. Yeah, it will tell there is no operating system. That's it. Yeah. Anyone else? Ajit said correctly. What are all things is how it's going to happen. Anyone else want to give a try? Same thing. Everyone seems to be sleeping mode. I think. Who are all from Bangalore here? I hope if anybody is from Bangalore here currently, they are safe. I heard things are not good in Bangalore.
Why sir? Too much of rain that side.
Yeah. So I hope if anyone is there in Bangalore, please be safe and take care of yourself.
Okay, sir. I am in Bangalore.
Please take care, dear.
Yes, sir.
Okay, so let me start here itself. Whenever you turn on your laptop, it's going to whenever you press the power button, it turns on. It will check the BIOS first of all. I hope you know the full form of BIOS. If not, then please Google it and get me in the assignment. What is the full form of BIOS?
Basic input output systems.
Sir, your voice not getting.
Sir,
Sir,
your voice is
voice not
missing.
audible.
Thank you for pointing out. Yep. So whenever your BIOS loads, or even before BIOS loading, there used to be a chip in your system, in your laptop or desktop, which holds the BIOS. And BIOS is a read-only memory. Goes into read-only memory ROM, and in that ROM there are several program already been written in BIOS, which runs as soon as you turn on your power, and it initializes several things, like your basic things, like your display, like your some part of CPU to execute fan. It will run fan, it checks fan how it's running or not. It does not initialize RAM, but it initializes, I think, SRAM and several other things, several minimal peripheral, what are all things are required for your system to be run. It initializes several things and present the information in this BIOS menu for you. When you open, you'll be able to see all the
Sir,
information. Yes.
Windows or Linux is directly BIOS is available in that, sir. We have to separately load the BIOS.
Oh man, that's very sad to know that actually. Okay, no problem. In every system, there is a BIOS. Without BIOS, there is no system. Okay.
Okay, sir. In case there
Even
is
though,
no BIOS, that's why I'm asking.
in case there is no BIOS, there is no operating system.
Okay.
Okay. In case there is no BIOS, for your laptop, I can say there is no operating system. But in case if there is no BIOS, there can be operating system, but only embedded operating system you can install without BIOS. Embedded operating system only you can install without BIOS. So which you are required to customize how to load, how to do things, what all things has to be done. But desktop or laptop made for a generic usage, and you never know a person whomsoever is going to come will install which operating system.
Sir, voice not audible.
Is it audible now?
Yeah, sir.
Yeah.
Yes, sir.
So what I was saying, like you cannot have any operating, you cannot have any generic operating system without BIOS. So what does it mean that you can have an embedded operating system without BIOS? Because whenever any manufacturer manufactures a system or the computer, he never know that which operating system user is going to use and what for the what purpose he is going to use. If you think that your user is going to use only this for this purpose and for this operating system, and this is the fixed set of devices he is going to use, then definitely you can skip BIOS and you can directly install the operating system. There's no wrong in that. Okay, so in embedded system, there used to be a small tiny uh, first stage bootloader, we call it. We don't call it BIOS at that time, but yes, first stage bootloader comes. So which picks up the bootloader, second stage bootloader from the system or from the embedded device and loads further. So here in terms of first stage bootloader, you can say that BIOS is playing a role as a ROM. So even though when we turn on this virtual machine, you will be able to see that it will ask for you to enter, go into a particular menu like F1, F2, F3 to give some option and go into the BIOS. So even this virtual machine also is having BIOS. Whenever you turn on, it might come for you maybe for a fraction of second, not even for a 1 second. So you may miss it. But yes, this virtual machine also, whenever you turn on the virtual machine, your virtual machine also gives option to go into BIOS menu. So my point here is like BIOS is the first program which runs and gather the information about all your system and devices which is already present, like hard disk, CPU, what is the RAM, what is the capacity of hard disk, and what is RAM, whether fan is available or not, whether RAM is available or not, and several other peripherals, whether that is available or not. It can check and let you know. Okay. Then this is the BIOS first stage. This is the BIOS. From BIOS, it goes to bootloader. So in hard disk, there is a separate portion. We call it as a what we call it as a mm, in hard disk, if we write a particular bit at a particular sector, that particular disk will be marked as bootable. Sometime you guys might have noticed that you have the people who has installed operating system on their own, they might need to create a pen drive, bootable pen drive. So some people might have seen that you are creating a bootable pen, you are copying the operating system into your pen drive, and you are not making bootable, and your that is why your system is not able to recognize your pen drive as a bootable medium, and that is why it's not able to boot from your pen drive, and hence you will not be able to install your operating system. So only thing you need to do is you have to make this pen drive as a bootable, so that your operating system recognize this as a bootable medium. And so for making this, there is a particular sector in that you need to write some bits, and which makes you can turn on some of the flags which makes this hard disk as a bootable. So whenever system turns on, BIOS comes into the picture, it checks all the devices, and in all the devices it checks that particular bits in the sector, and which are all having available flag in those sector, it will mark those disk here that yes, these systems, these three disk, pen drive or CD drive is available to boot. Okay, if those bits are not available, this will not be able to recognize. So you have to make sure that your disk or hard disk is bootable. So this bootloader first part gets written in this sector. So BIOS transfer its execution to bootloader through this bootable bit, I can say, or through the bootable program. So what kind of bootloader we have available? We have available Grub, sorry, Lilo, or Grub2. Grub or Grub2, it's a what to say, another version of Grub itself, and Lilo is another bootloader. Okay, and uboot is also a bootloader. This is for embedded devices, and this Grub and Lilo and Grub2, these three are basically for your general operating system. There are several other bootloaders also, but I'm not going to concentrate on those. And in our system, we are using Grub and Grub2.
Your voice is not good.
I'm audible now.
Yes, sir.
Yeah, thank you. So what I was saying is like, yeah, you will have Grub, Grub2, or Lido, or U-boot. U-boot is for your embedded devices, so which we'll not talk about. Lilo was an old bootloader, and nowadays, all most of the Linux uses Grub or Grub2. Okay, so I want everybody to note down the Grub abbreviation also in assignment. What the Grub stands for. Please don't paste it here. Okay. I know some people does know. So from BIOS, it will go to bootloader. So it may go to Grub or Grub2, the execution, and what Grub will do. Just give me a second. Okay, fine. So I was checking that what people says that after Grub, what is going to start? What Ubuntu people says. Because I do explain. I don't go much into deeper. So after grub 2, it goes to kernel. Before kernel and grub 2 also there are several things which happens actually. Okay, and when it goes to the kernel, after loading the kernel, it loads the initramfs. Initramfs is initial RAM file system. When it loads this, it will start the init process, which will have the PID 0. And after starting the init process, it will start further other processes. I'll explain what grub 2 does, what kernel does, what is in initramfs. I'll explain once again. But here I'm just trying to explain the flow. So init process will have PID 0. Please note it down because in several interview you will be get asked, and this booting process also you will be get asked in several interview, because you should know your system may get stuck at this point also sometime. Your system may get stuck at this point also sometime, or at this point also sometime. So it's your job to debug it. Sometimes you need to debug at this point itself, grub to itself. Sometimes you are required to go here and debug that. Okay, so these are all several stages which uh, you might not see in normal booting process, but actually these processes are there. So let me be here itself. So init process will come back and with the PID number 0. PID number is a process ID. So whenever any process comes up in Linux, it does have a number. That number we call it as a process ID, PID. And in Linux, first process is init, and in some places, first process they call it as a system D. Okay, but it's an init process only, but they named it as a system D. So how to see the process and PID, I'll talk about that later, not now. Okay, and after init there are several other things which comes into the picture and which gets initialized. Okay, like you may see that networking get initialized, your what to say, your graphics display manager get initialized. All those things is already there, which get initialized after that. You might have seen that during loading of initramfs itself, uh, there used to be either in Ubuntu or CentOS, there used to be a bar which keeps on going, and when it completes, your login screen comes up. When it completes, your login screen comes up. So that's called as a play mouth screen, or some other name is also there. I'm just missing. I'm not able to recall it. We'll see during the login what it's saying. Okay, and during initramfs itself, there used to be several scripts through which this is the play mouth screen, which starts in the first itself. After that, it mount all the file system. I think I need not to tell what is called file system now, and everybody understand what is called mounting of a file system. Okay, Then it brings up the network. Then it brings up the GDM, graphics display manager, or I can say display manager, not GDM. And there are several. Let me clear this. Yeah, so first of all, what it is going to come is BIOS, bootloader, kernel. Bootloader can have Grub or Grub2 kernel, and then initram fs. During initram fs only, all things will start, like Plymouth is called in Ubuntu. I'll see what is called in CentOS. Maybe some, I don't remember. We'll see that. And after Plymouth, it is going to mount all the devices or file system. After that, it's going to initialize networks. After that, it's going to start display manager. Display manager, there are different types of different display manager, like GDM, KDE, XFCE, XDM. GDM is graphics display manager. KDE, I don't understand what it stands for, but GDM is used in both CentOS, Red Hat. KDE is used basically in OpenSUSE. XFCE, I don't see by default where it has been used, but if you want this to be as your display manager, you can use XFCE. The main advantage of XFCE is it's very much lightweight. It's very much lightweight, and it hardly takes much RAM during loading of this. A heavy RAM takes by KDE. XDM is also a display manager, and there are several other display manager comes. Okay, so this is the last display manager stage, and not last actually. I should not say last. And as soon as your display manager come at this point of time, only your scripts boots up in from rc.local. There is a file which we call it as rc.local, and in that file only, if you want to keep something to boot when your system starts, that file triggers and plays the role rc.local. Okay, so I have told several information today. You need to remember all the things and remember it first of all. Okay, so this is the booting process of a normal Linux system. BIOS will consist of all the information regarding your existing system. Now, what bootloader is going to do? Bootloader is going to initialize your RAM, and it's going to initialize the space in RAM so that it loads. It can, first of all, it's going to initialize the RAM, and the spaces in RAM it's going to initialize so that this kernel it can load into this RAM, and this init ramfs it can be get loaded into this RAM. Okay, so it initializes this, and it initializes the minimum hardware like CPU, RAM, and several other SRAM or DRAM, and several other peripherals, which is bare minimum required to start the operating system. So let's say it's loaded the kernel from here, from the hard disk, and in ramfs it's loaded from the hard disk. After loading the kernel, it expands the kernel, and it expands after it expands the kernel, and it loads the module. Loading module means loading the driver. After loading the module or after loading the driver, it expands the init ramfs, and it loads the init ramfs also. So let's say you are if you don't have space left in your device while expanding the init ramfs, please pay attention here what I'm trying to say. If it's expanding the init ramfs and kernel, which will be available in a compressed form. I will show you the files. Okay, let me show right away itself, then you will have a better understanding. Okay, I can show you here itself. The same thing is available for CentOS also. uh, Desktop document. Okay, control L, root. I go to boot. System map, init rd, VM lineage. Init rd and VM lineage is going to be get extracted as part of your ramfs and kernel. Correct, I said. Let me see which one is kernel. This is EFI boot. This is loader. No. Okay, so your kernel is here in VM lineage. Okay, and init rd will have your root file system. Here it's available. So first of all, your from this device, this is the UUID of the device. Okay, I will show this information. All this information I have opened. I will show you that where it's displaying. So VM liner, this is the file which is called grub.cfg actually, which will have the configuration of the grub, which I was talking about some time back. So this is your kernel, and this will start your file system, compressed file system, and you can see those two here. VM lineage, it's again a compressed file, and init.rd, you can see that it's a compressed. Okay, so these are all the two files which is going to get expanded. System.map, it will have the mapping of all the system calls, which I will not go deep into. Okay, so let me share the older screen again. So you have seen this. Uh, where it is? Where it is? Kernel and init ramfs. Okay, so this will get extended. So where I was, let's say if your init ramfs is getting extended, and in that at that time you don't have space. So what will happen? Your prompt, your system will not boot, and it will get stuck at init ramfs only. Init ramfs. It will give prompt. That's it. Black screen will come. Your cursor will be here. So you need to recognize this, that it's we are at initramfs and we got stuck. And before that itself, it will I mean during this time itself, during boot time itself, it will show that your system does not have enough memory to boot. Okay, so that may happen. And let's say if you deleted this initramfs file itself, then after booting kernel, it will say I don't have root file system, so I cannot boot. Okay, so you need to understand that at which point what it is not able to find out, and then what error it's throwing. Then only you will be able to recover that system. So let's say if you have removed this kernel file itself, it will say that hey, I don't have kernel, so I can't boot. I don't have root file system, so I can't boot. I can't go ahead. So it is required first this, it is required first this. After that, the initramfs, and after that it comes all these things in place. So kernel is going to load all the drivers and initialize the system, and after that initramfs is going to load the root file system. Root file system, when you see the directory called root and then slash boot, then slash etc slash spin, so it is kept compressed. There are several others, it's all kept compressed in initramfs. So these things is going to be get extracted, and on the top of that, what all things, what all script has been written in has been etc or boot, it's going to be get executed during this boot time. And after lastly, when your display manager comes, at that time everything would have already been booted and you will be presented with a boot screen. That is what has happened. That is what is going to happen now. Let me do that. You'll be able to see as soon as I'm pressing this start button here, it will show me that a boot menu. Let's see. I press F12 to select the boot menu. You might have seen that Grub has already, that BIOS has already gone there. It might come for fraction of second. Let me show you again here. I'm just going to start. You'll see at the bottom. Press F12 to select boot device. At that time itself, BIOS is gone. Now we are at a Grub stage. In Grub stage, I have there will be a timer which is running, which used to run in normal Linux system. Okay, I will show you the timer also. This is a timer 5, 4, 3, 2, 1. To stop this, I need to press a key. Any key, if I press, it will stop the timer. So what I generally do, I do press up arrow key or down arrow key. Okay, to stop the timer. Now we are into Grub, which we spoke about few minutes back, and we can see the information what Grub is doing actually. You can press E and you can go inside the grub and you can see all these things. What all things is doing. I've shown you a grub.cfg file actually. Okay, so this all this information is coming from grub.cfg file. All this information, whatever you are seeing, you can see that linux slash boot equals to vm lineage, and this is the uuid. Uuid is a id assigned to your hard disk, and these are all several parameters for the kernel, and this is from where to boot from. .img, it's compressed into .img. We can see that this root file system where to pick and boot from. We'll come back here whenever there is a requirement to debug the system. Okay, so this is a grub, and it has several information, like it wanted to load video or not, ins mode gzio, ins mode part ms-dos, ins mode xfs. You can see that you might be able to remember that what is this ins mode is. This ins mode command is for what purpose. Now you will be able to identify that what it is doing at this point of time. Okay, it's trying to load the gzio module so that it can compress or it can extract further these modules, whatever the compressed module it's going to get. So for extracting these things, it needs to have an extraction program which is getting loaded here, and it's trying to load ms-dos also at some point of time. xfs also it's trying to load, because xfs is the file system which this will be get expanded on initmfs. So that's why it's loading, and these are all the several kernel argument which it's passing to boot your system. So you're not required to modify any unless you know what you are doing. Okay, so come out of it, you are required to press escape, and then if I want to boot this, I will press enter. And as soon as I press enter, there will be a menu which in the graph will keep on going, the bar will keep on going. So to skip that bar or to do not show that bar, I will press right arrow key actually. So let me do that. I'll press enter. So you can see that, let's come. Oh, it's not coming. It directly comes with the boot screen itself. So that play mouth menu is not coming for me. Okay. Okay, so it's gave me the login screen itself. So let me reboot the system again. So I wanted to show you that after pressing the right arrow key, after the kernel boots up, kernel is booting. During the kernel is booting, I'll press the right arrow key. Oh man, it's not showing here anything. No, it's not showing. For me, it's not showing. So before my command goes to the operating system, it's booted actually. So where I can show you in Ubuntu here, can I show you? Let me give a try to show here. The execution is way fast that it's not able to take my inputs actually from the keyboard. So maybe if I reduce the RAM or if I reduce the processor, and I can slow down the system At that time, I may see the effect of pressing a key. So whenever I press a key, it should give me the flow of execution, the way it's going, or which are all things it's getting installed. That's what I wanted to show, but it's not coming. Okay. So actually, this is the thing which is going to get displayed whenever playmouth comes into the picture. So you can see that starting a file from this, it started booting, and then it did not show that the kernel is booting, because when kernel loads the file system, then only it's initialize anything and it starts the logging. Okay, so it's started loading the file system, and for the init rd or init ramfs, you can see that several other things. Now after that, it started to initialize further file system and further processes, user space things. And you wanted to see what has happened into the kernel. For that, you need to go to this menu, the message. You can see that it's boot image, VM lineage. I told you VM lineage, it's booting from here. VM lineage will have the kernel. I told you that, the compressed kernel. So it's just extracting. This is the first line. Everybody is able to see that. This is the first line, because it's not fully displayed. So yeah, okay. So here you are able to see that VM Linux is getting booted, and from this file system, and after that, this is RAM areas is getting initialized through the BIOS, and then it's further other things, other modules is getting initialized. It's get to know that it's booting on a hypervisor itself. It's booting on a virtual machine. So what are all things need to be updated? EA20 it has to be updated, and usable reserved memory. So there are several other things has to come up. Okay, several devices it's installing, it's starting. This is again a memory initialization of zones, DMA zones. So all these things are there. Okay, so this is coming from the kernel, and after kernel finishes, transfer goes back to initramfs, and for initramfs booting, you will be able to find out those things in boot.log. Okay, so these are all the two places where you can find out what is happening at which level. So after this, your system is up and running. Now how to debug it? Let's say sometimes you don't get this prompt itself. Okay, let me add this here. We got into this issue, correct? Last time. So let's wait for reboot on the next second. Oh, it's 8, so we have to wait for more time. Till then, wait. So cron tab plays the role, and it's going to boot, and after booting, it's going to reboot again. So you need to suspect, you need to identify a reason here, why it's happening, and then you need to act accordingly. So let's say system is booting, and then after booting, as soon as you got into this root prompt, it started rebooting again. You didn't get a chance to look over it. So you need to suspect what could be the possible reason why it's rebooting again and again. And then you need to debug it. So from where to debug? You need to go back to Grub and then start debugging. So let's let it reboot. And then here I will stop the timer by pressing up or down key. After stopping this timer, I'll press E, and after that, after pressing E, I will go to this line. Which line? Which line? Which line? Yep. This line, wherever our kernel is loading, I'll go to the end of this line, and I will delete this key. I will delete till quiet, and I will write rw space init equals to slash bin slash bash. So I am executing. I wanted to tell that please mount this file system in read write mode by using this read write, and I want init to start with bin bash. So previously init was starting with its own predefined things, and it was further executing all the script which has defined in the operating system. But I wanted that to get replaced with only terminal. So first give me terminal, don't initialize anything, don't start anything at all. So you will not have anything in this. You will not have network. You will not have many things. So only file system mounted with read write mode. That's all. So I'll press. So yeah, how to execute? Now I have written this line, and you need to write down in this line only after deleting whatever we have deleted. And after that, you are required to press Ctrl X. You can see that here. Press Ctrl X to start. So you need to press Ctrl X to start your changes here, whatever you have made the changes. So I'm pressing Ctrl X now. It's starting. You can see that you are able to see all the menu, whatever we have showed you from the message. One that's next time. Yeah, we have got the bash here. Okay. Now you should have already suspected that what could be the issue. Now I will check vi etc cron tab. I'll go check I'm able to access the file. I will delete this line. I'll escape. I'll simply close and I will exit it. And this is the place where you can change the password also if you want without knowing anybody else. Let's say you have missed the root password, you have missed your user password. I do see I have test user 1, user 2, user 3. I can PSSW user 3 password. I can change. It's got changed. So without knowing user also, you will be able to change the password here by bypassing that user and going into the user, logging into the user. You without logging also you can do this and you can change the password. So basically, this is not for that purpose. This is for the debugging purpose. You can use it if you face any issues. Okay. So reboot should not work. Yeah, reboot doesn't work here. So I need to press Ctrl Alt Delete here to reboot the system. I need to insert Ctrl to Del. It's not taking. Mm, Okay, let's reset itself then. So let it reboot, and we should be able to see that what are all changes we have done, whether it's reflecting or not. What happened? Keyboard got changed. This is not good. If it's not taking, I need to go there and reset password again, and I need to find out how to reboot that without resetting. Hmm. Okay. Let me see the changes, whether I have changes or not. Yep, I have the changes. Not recovered. Hmm. So what all changes I'm doing, it's not writing, or before reboot, it's taking something else. Mhm. I need to find out how to send control to Dell here. Okay, so which writes everything, whatever I wanted. Because resetting doesn't seems to be writing the password, or it's changing the file, the hash keys of the password. User one should be Let's change everything. Yeah. Hmm. Okay, I'll debug this later and I'll see what is the debugging thing is coming up and I will update you guys. Okay, the username password. I'll see what has happened with this. So as of now, I'll close this virtual machine. I'll turn off. Let's turn it on this one. It is yet to install. Is it so? We have not installed it. I think we have installed it. Let me turn it off. Optical disk. Remove. Reset this. Yep. Okay, so anyone has any doubt in what are all things we have gone through yet? Okay, so there is another method also which you can utilize for recovering your system. You can go to this rescue mode from the BIOS. You can go there. Why it's happening unexpected things? This is not expected. From the recovery mode, this is not expected. It should go in some other way. If that is also not working, yeah, this is also not working. So another recovery way is here, which for sure definitely will work. What I'm going to do is I'm going to mount this CD drive and I'm going to reboot this system. Mhm. And it's going to get rebooted from the CD drive or DVD drive. After that, I will start the troubleshooting from here. Rescue CentOS system. This is another method to rescue your CentOS. So let's say if your Grub itself, where you are editing your things, You are editing your things in Grub, correct? So let's say the Grub itself got corrupted. Then what you will do? At that time, you have to come back here and start the things. Here you are required to give option 1 to continue. Now it's asking for chroot slash mlt slash symh. Sorry, I have done chroot. Now we have got a prompt. So this is equal to what we have done there. Okay, let me try the same thing there also to get the to reset the password whether it's working or not in that another system. I will power off this machine immediately. I'll go to CentOS. I'll go to the settings and storage empty. I will connect the DVD CentOS. I'll press OK and then I'll start this. So now I'm starting from the CD drive in troubleshooting rescue CentOS system. Now I will remove. I have done the chroot, so I have got the prompt of that window running operating system. Now I have removed the CD drive and I'm booting. Let's see if it's working or not. What are the changes we have made? This is another way of doing things. This is another way of going inside the system and doing changes. So this method you need to use whenever your grub itself is got corrupted and you don't have any prompt to go inside your system. You can see that we recovered the password. So that there are two methods, one through grub and another through the DVD itself. So we have done one more extra thing here. Not I mean in the DVD method, we have done a chroot. You'll be able to understand chroot. What is that? Actually, I will explain that in short. What we are doing in chroot. What is the meaning of chroot? My screen is visible to everyone. Let me
Yes,
see
sir.
whether yeah, it's visible. Yeah. So chroot. So ls space root. So this is the root actually. This is the root file system. share something else. Where is the paint? I want to save. So where what happens whenever you know that this is your computer, it boots from BIOS, then you know it boots from Grub, then it goes to kernel, then it goes to initramfs. Okay, so when it loads initramfs, it's going to load the file system slash root slash bin slash slash sbin and several other it's going to load. So what happened is when we are inserting the CD drive after BIOS, this from this itself it got interrupted. Your execution starts first in BIOS, then it has reached to CD drive. Now CD drive is booting. So when CD drive is booting, the same system, the same thing is going to be get followed with CD drive also. When we are booting in rescue mode, it is going to check that what all devices are present in this system. In this system, what all devices are present. In rescue mode, it's going to check. And it's going to mount those devices with the help of the CD-ROM onto the RAM. It's going to mount devices with read-write permission onto RAM. This CD drive will do. So what happens is, what are all things we have here? This file system, let's say it's written in slash dev slash sda2. Okay, because slash dev slash sda1 will go to swap, and this will go to your root file system sda2. So now what is happening when we have our CD up and running at this point of time? We have our own operating. Let's say if you're not going to the rescue mode, let's forget about the rescue mode right now. If you're not going into the rescue mode, you will have your own operating system running on RAM, correct? And it will have its own it will have its own file system, everything. So now this CD here also in rescue mode also, if we go, it's running on the same its own file system, which does not have anything to do with kernel, with the existing kernel which is into your hard disk and which is corrupted, or which I have forgot the password currently right now. It doesn't, it needs, it's don't have anything to do with this root file system. So first of all, CD is going to boot, it's going to load its own file system. After loading its own file system, it's going to check which are all devices are present. It will check SDA1, SDA2 is present. It will check SDA2 is having a bootloader. So it automatically detects SDA2 has a bootloader. So it will ask us to do a chroot slash mnt slash sysimage. What will happen after this? After this, this file system will get mounted on this platform and it will give us the bash. You might have seen that we have got bash 4.2 hash, correct? When we have gone into the rescue mode. So when we have got bash, the bash is not from this actually. After doing chroot, whatever bash we have got, that bash is not from this CD drive. The bash is coming from here. Sorry, this bash is coming from here. So it means like we have got a terminal of this file system which is sitting inside another hard disk. So that is also possible in Linux, that you can grab the terminal of a file system which is simply sitting. You are not running that event. You can grab the terminal and make the changes, and you can, after that, you can boot from here. So we have grabbed the terminal. We have seen that bash 4.0. After getting the terminal, we have we have made the changes. We have modified the password by using PSSWD password, and after that we have rebooted the system. After rebooting, we have exited the CD drive and we have proceeded with the normal booting process. And when after proceeding normal booting process, when we have given the password, it's working now. Everybody has seen that here. And this, correct? So this is the second method of rescuing the system through DVD or CD. And the previous one was rescuing the system through Grub. So the second method will you can use if your Grub itself is not working. You can recover your Grub also with the with the second method. Okay. So I will upload this video and I will add up a link. So, okay, let me finish this class first. So anybody has any doubt here in this class, in this session? Okay, if no doubt, then let's close this class here itself.